Howdy, my name is Tate Turner. I'm here with Zack Michaelson and Alex Ryan for our applications for Thermodynamics and Kinetics extra credit assignment. Question 1A. The factors that affect standard molar entropy are moles, temperature, states of matter, and complexity. Given that the moles in this reaction decrease from 4 to 2, it becomes more ordered, and therefore the standard molar entropy of this reaction is negative. Question 1B. The sign of the standard molar entropy of the surroundings is positive. The equation for this is standard molar entropy of the surroundings equals negative change in enthalpy over temperature. Since the reaction is exothermic, it will have a negative sign, and a negative times a negative equals a positive. Since this is an exothermic reaction, the K value would be lowered as you increase the temperature. Using the Gibbs free energy equation, which is Gibbs free energy equals change in enthalpy minus temperature times the change in standard molar entropy of the system. Since the standard molar entropy of the system is negative, a higher temperature will make Gibbs free energy less negative, therefore hurting the spontaneity of this reaction. Question 1C. Analyzing the standard Gibbs free energy versus temperature graph. The y-intercept for this graph is the change in enthalpy for this reaction, and the x-intercept shows where delta G, the change in Gibbs free energy, equals 0. Whenever this line is below our x-axis, that means that the standard Gibbs free energy has a negative value, and therefore it is spontaneous. When it is above the x-axis, the standard Gibbs free energy has a positive value, and therefore it is non-spontaneous.
So when asked what increasing pressure of reactants would do, according to Le Chatelier's principle, increasing the reactant pressure would cause the reaction to move forward to consume that increased pressure, which would make Q less than K, therefore moving forward. And a lower Q would decrease natural log of Q, which then would decrease delta G, especially if L and Q is less than 1, which would make that value negative. And then we can see that because of these, the reason that high pressure and high temperature is used is because a lower Q, Q less than K, would move it forward spontaneously. And then, although this is an exothermic reaction, and ideally under Le Chatelier, increasing temperature would hurt the spontaneity of the reaction, using that Gibbs free equation, we can see that a low Q plus a high temperature would keep the change in Gibbs free energy low, especially if Q is less than 1, which would make it always negative.
What is activation energy? Since the equation of the line is y equals negative 60,523 x minus 28.203, and we know that slope equals negative activation energy over r, we can solve for activation energy by multiplying the slope by the r constant, giving us an activation energy of 503.188 kilojoules per mole. A catalyst is used to speed up the reaction by lowering the activation energy and increasing the K, which negative activation energy over R is the slope of the graph, and having a lower activation energy would mean a less negative slope or a less steep slope. And calculate Q, in which direction is the reaction spontaneous. Since we're given K at 4.3 times 10 to the negative 3, and using the concentrations of the products and reactants to find the Q of 6.4 times 10 to the negative 3, we know that Q is greater than K, meaning the reaction will proceed backwards spontaneously. And if the system reaches equilibrium, the pressures would be N2 is 51.85 atmospheres, and H2 would be 55.55 atmospheres. And we can find this by using ice tables.